the most interesting area in HPC now is the advent of AI as part of HPC. So we used to be in a world where we were running conventional HPC simulations, and now what we're seeing is, in 2019 we had AI just rising up, and now we're seeing the two really form together. So HPC is no longer standalone. It very often now has an element of AI which accelerates the end-to-end HPC simulation process. And we've seen customers tackle this in various ways, and now we're really at the peak of demand of that converged HPC and AI. And it's only going to get easier from here. We've been through the hard bit of the integration, and now I think we're starting to see standard applications leveraging AI day to day. In the AI pipeline, we start by ingesting data, then typically we will tag and apply metadata to that data, then we'll train, then we'll inference, and then we'll store and have a feedback cycle around this loop. So in there, let's pick three areas of contention. One is ingest. How do you get the data into an AI system in the first place? And we say that's a problem because some of our customers are really very, very large scale. Our autonomous driving customers have 200 terabytes per vehicle, per car, per city, and these volumes go very, very high. So from a storage perspective, it's about bringing the data in and doing that fast. Number two, when we come along to the deep learning and the inference phase, there's kind of the opposite going on. We've got to do this random reads, and this is a different sort of problem. And what we've been finding as things have been maturing is it's not only a read process, but very often there's a very intensive write process involved there, because as you train a program, you often want to basically pause and checkpoint the data so that you can later bring the application back to life from where it had been paused and move forward. And that happens for more than one reason. So it's a complicated I/O problem right there. And then finally, moving down this pipeline, thinking about storing. Well, in AI, it's never really storing. You very often want to bring that data back and bring it back into the process. So it means the volumes of data get larger and larger and larger. And so the challenge really has been to build economically viable, very large scale systems to manage that volume of data and keep it active. I like to think of the AI data pipeline. Data comes in, you tag and label it, the data gets put into a model training phase to train those models. Then you go to an inference phase, you go into production, and then you store the data. And that storage of data is more active than non-active. The data often gets reused. We usually pick out like three areas of difficulty in this areas of the pipeline. And number one is just that first part, ingest. When it comes to ingesting, different companies do different things, but for one example, autonomous driving customer of ours, they have many vehicles in many cities and in many countries, and each vehicle, each day, is putting in 200 terabytes of data. It's a huge amount of data. And of course, you've got to ingest that multiple times per day into a storage system in order that you can make use out of that data. So that's problem number one, ingest. And for the storage system, it's a write problem. So the storage must be good at fast writes. Then moving along this pipeline, you're going to a deep learning phase. And deep learning, model training, the more data the better. And it used to be known as just a conventional read problem, this random read. And so you're reading data from the storage and then you're training this model. But more and more often, as these models get larger, there's a bigger requirement to checkpoint the data. That means we're going to run the model through part of its phase, and we're going to then dump the memory. So dump the state of that application to the storage, because either there might be a failure somewhere, you don't want to lose it all and go back to square one, or you might see that the model is not being trained perfectly and you want to adjust the parameter set. So that checkpoint means we want to write data and do it very, very quickly. And over time, that's become a much more important problem, an I/O challenge for storage systems. And then finally, just thinking about the end of the chain, that's not really the end, is you want to store this data, and because it's deep learning, the more data the better, and these data volumes get huge. Some of our customers have 500 petabytes of data. But you need to keep it active. There's no good in putting it back in S3 or back in a tape library. It needs to stay active. And so having an economical way of storing vast amounts of data and keeping it active is the kind of final third big challenge. I think fundamentally, it always comes down to people. DDN's been a company that's been around for 20 years, and during those 20 years, we've been working with customers who genuinely do the toughest data I/O challenges in the world, whether that's in HPC supercomputing or in AI or in analytics. And we've learned from them, and we've implemented stuff for them, and essentially our people now have the genetics, if you like, and the company has the culture, so that we focus on our customers, how to overcome those inevitable issues that do happen. And we've also got the software and hardware smarts to help people scale properly. So in a very sort of short summary of that question, it's really about the people and culture of DDN. We focus 100% on storage and data management, and all our people have that really deep in their hearts and the skills to help customers get over their pitfalls. Are there any shifts in the AI landscape that people really should be paying attention to? Well, I think there's many shifts actually, a lot of them small, a lot of them big. Think about a couple of the big ones though. So far we've seen AI being used at large scale, what we consider large scale. The models often have 500 million parameters for natural language processing. The autonomous driving systems have hundreds of petabytes data. But the biggest shift, kind of quite surprising to me, is going to be that's going to get a lot bigger. So we will be talking about not about 500 million parameters, but maybe multiple billions very, very soon in order to take advantage of the data potential that's in that data. Same with the volumes of data, it's getting much bigger. So if people are surprised by where we are today and what's happened in the past few years, I think there's many more surprises to come. And there's many companies springing up, delivering new hardware, new CPUs and IPUs into this AI ecosystem. They're going to have a different way of treating different problems. And actually our partnership with NVIDIA has been kind of interesting because they've been moving into this world of really building AI factories and simulating extremely sophisticated and complex ecosystems on the planet, whether that be the Earth and weather systems, or whether it be kind of factory processes or whatever. So we're seeing digital twins being developed through the power of AI, and that's going to make a dramatic difference in the next few years. So I'd say my advice for companies with data, or potential of data, is really pay attention to this area because I think you've seen nothing yet. So how do we see the approaches to AI data management changing over the next few years? So I think volumes change. As I said, we're going to see, even though it's been big so far, it's going to get much bigger in terms of the number of parameters, the amount of data, all the data we're using, video data, image data. Not only do we get more of it, but over time it gets inevitably more precise. And more precision means bigger volumes of data. So sheer volumes are big. What I see genuinely changing though is, today we tend to move data to a central point and tend to do big scale analytics there, major large scale deep learning in major data centers. And we'll see this creep out towards the edge. So some applications will want to see their super fast latency response using AI, even though somebody might be out in the field. I mean, literally they might be a farmer out in the field and using an app to perform some kind of analytics, but they want a response immediately. And that will happen at the edge. So the analytics, the compute piece, today it's largely centralized, but I think that'll become decentralized. There'll still be a need for it in the big data centers, but you'll start seeing it regionally and start seeing analytics happening in very small scale at the edge, very close to consumer devices. So DDN is the AI data company. We build the largest, most scalable systems that start small, but scale to huge scales, and our people, our processes, our software, our hardware, the whole company is centered around helping our customers overcome the toughest data challenges in the world.